So everything is made out of triangles. So here's a bunch of triangular meshes. These are all computer graphics things. And some of them look like they're smooth rendered like this face. And some of them you can see the triangles because there's fewer triangles here. But all of these things are made of triangles at a lower level. So how can that be? And how long has this been true? So on the left, we see some computer graphics things, which you're probably more used to seeing. And we can see how shapes might be made out of triangles. And on the right, we see an ancient drawing from hundreds of years ago, where they were in fact breaking objects down into parts to try to understand how to draw things in art. So this idea is nothing new. So here's a bunny. And when we zoom back, we see the whole bunny. But as we start to zoom in, we can see, here's the triangles, here's more zoomed in. So I'm gonna show this now. So here's our bunny. And as we zoom in, I don't see the triangles yet, so I need to change my rendering mode so that I can see my triangles. Over here, we'll talk about this later in the course, you can see that we have a near clipping plane that's going out of whack. So I'm gonna adjust that a little bit. So here's my triangles. And as I move around, the triangles in their world coordinate are not changing, right? There's some absolute Euclidean coordinate system where this bunny is sitting, right? And what I'm changing is my angle of my camera to look at it. And these triangles get mapped on the screen. So in some sense, this is the lowest level operation we need to do in computer graphics. This triangle, let me go see if I can get an individual triangle here. Well, I'm not sure if it's gonna work. It's updating very slowly. But anyway, an individual triangle here has some world coordinate system in XYZ, and its position on the screen is going to move each time we move this mesh. And our goal is to figure out where is it going to land on this screen. It's supposed to be showing some information about the coordinate points, but it didn't work out. So where do each of these points go when we're drawing the triangles? Also, where do the triangles come from? It's all nice that I have this mesh, but it's unlikely an artist drew each one of these little triangles on this mesh. So there's two places the triangles come from. One is from modeling software. So on the right, we see, I don't remember if this is Maya or Blender or what is this, but there's a variety of modeling packages. And artists use these, and they have some higher level tools to draw the shape they're drawing. And then they all get broken down into triangles by the time they're passed to the computer graphics, the part that we're writing in this class. You can also have a 3D scanner. This is from a company called Cyberware. It's a full body scanner. Each one of these yellow boxes shoots out a laser and has a camera that sees the position of the laser. And the whole thing moves up and down on a robotic arm. So you stand here and the machine moves like a robotic motion. And then you end up with a scan of the whole human body. So this is another place that triangles come from. Laser scanners especially generate too many triangles. So here's some teeth that were put into some kind of scanner, and there's 400,000 triangles in here. Well, that's probably more than we need. If we were gonna stick this in, say we're making a basketball game, and these are going in the basketball player, and they're on the other side of their court, and there's 20 different players in view, I probably don't need 400,000 triangles to describe the teeth. I can simplify. So there's a concept of level of detail. So we might store our objects, instead of 400,000, maybe I only need 1,000. If they're really far on the screen, maybe I only need one. I don't really need to store triangles for the teeth, right? But you can simplify, and this notion of level of detail, although it's not something we're gonna have to deal with in this class so much, is something that comes up when we're trying to store real objects.